Use an elimination strategy to solve each linear system. Okay, so again, elimination means we need to try and get a situation where we have, for the same variable, we have a positive and negative of the same number, right? An opposite coefficient. So this, right now I have a plus 1x in front of, plus 1 in front of this x, and I have a plus 1 in front of this x. So to me, this one is pretty easy to change one of these equations to make one of them negative. So I'm going to change the second one, which really means that I multiply a negative 1 times each of the terms. And so this becomes a negative x plus 2y equals plus 1. Okay, so this is my new equation for equation number 2 there. Here's equation number 1, and here's my new equation number 2. Everybody understand that? So you can just kind of scratch that off for now. We're not going to use that one. Instead, and I'll rewrite them actually. I'm going to rewrite them. So I have x minus 4y equals 1, and negative x plus 2y equals 1. Please make sure that the variables are right on top of each other, and the x terms are on top of each other, the y terms are on top of each other, the equal signs are lined up, and then the constants. That's usually how they give it to you. But just make sure that all the terms are exactly kind of like right above each other, and the equal signs are in the same spot. Then you can simply add each of the terms. Okay, so now we're adding this. So x minus x is just 0x. So you don't have to write the 0, but that's the whole point, is to eliminate one of those variables. And then negative 4 plus 2 is negative 2y equals 1 plus 1 is 2. All right, everybody okay with that step there? Any questions about that step? That makes sense? All right, y is 2 over negative 2, or y equals negative 1. Now, I usually just do that, say, okay, I've got that so far, I'm not quite done the question, and I haven't checked it. So what do we do next? Anybody remember? Plug it into, what should I plug it into? Yeah, one of the original equations is what you should do. Plug it into one of the original equations. So I'm going to come back up here. I'm going to try that first one, the first equation. So x, I don't know yet, minus 4 times y is negative 1 equals 1. That's x plus 4 equals 1. X equals, I'm going to subtract 4 from both sides, is negative 3. How does that look? Does that look okay? All right, so let's check. And I'm going to plug negative 3 and 1 into both equations to make sure that they both work. So negative 3 minus 4 times negative 1 equals 1. That's negative 3 plus 4 equals 1. That looks good. And the second equation, I'll use the original one again just to make sure I haven't made any mistakes. So original equation, I'll use different color. Negative 3 minus 2 times negative 1 equals negative 1. And so that's negative 3 plus 2 is negative 1, and that is correct. So here are our two solutions, checked and verified. Okay? Good? Yeah, got that? Okay. Any questions? Okay. Sorry? Clear as mud? Okay. All right, you do B right now on your own. Do B on your own, and then we'll check your answer, okay? So do B right now on your own. Okay, I'm not sure if you're done B yet. Some of you have done B already, I see. So that's good. If you're still working on it, go ahead and keep working on it. I'm going to start here. So what I really like is the fact that I have a plus B and a minus B right there. So you don't have to do anything. You don't have to multiply any of these equations at all yet, at first. So you can just simply add them now, because you will eliminate that b, right? So 3a and 9a is 12a. Negative b and positive b, when you add those up, it gets you 0, so that's great. Equals 5 plus 15 is 20. Okay, everybody see that so far? So a is 20 over 12, and we should simplify that. Can we simplify that? Divide both by 4. 5 over 3. So a is 5 over 3. Good. And let's substitute that back in to one of the equations. So 3 times 5 over 3 plus b equals 5. The 3's cancel out when you multiply those, so that's just 5 plus b equals 5. b equals, subtract 5 from both sides, you get 0. So b is 0. Let's see. All right, so let's check those real quick. And 3 times 5 over 3 plus 0 equals 5. Yep, that's 5 equals 5. That one's good for the first equation. Let's check the second equation. 9 times 5 over 3 minus 0 is 15. So 9 over 3 simplifies to 3 over 1. So we have 3, and I'll write this out just to show you what I did there. 9 over 3 simplifies to 3 over 1, see? So that's 3 times 5 is 15, minus 0 is 15. That works too. So A is 5 over 3, and B is 0. Any questions on that one? Okay, some of you look confident, some of you don't. Do you have any questions? Those of you that might be looking like this? It's never a good sign. I don't know. Are the fractions tough, or? It's not the end of the world if you change this to a decimal and then use your calculator. That's okay. Because you guys are the AP group, I want to make sure that you know how to use fractions. You need to know how to use fractions, need to be comfortable with them, so fractions are pretty important. That's why I usually leave them as fractions. Okay. Anything else for that one? Okay. Let's quickly do one from number 6. Number 6 looks like we might have to multiply both equations by something. So let's do 6a, and then I'll let you do 6b if you haven't done that yet. But okay, so 6a. Again, the variables are in the proper columns, so that's good. I see 2x and 3x. I can't eliminate if I just add those. I can't eliminate if I just add those. So I'm gonna have to change something. What do you guys want to do? What are some ideas? What could I multiply both equations by to eliminate one of those variables? Okay, I can multiply the top by -5. That would help this term be a -5y, and it would add, yeah, that's probably the simplest one. That way you only have to multiply one equation. So that, I like that. That's really good. The other one, if you wanted to eliminate the x, you would have to multiply both equations, and you'd have to multiply this one by a 3 maybe, and this one by a -2 to get 6 and -6, right? So you'd have to multiply both equations by something to eliminate the x. But the y, that's a good spot there, times -5. Okay? -10x minus 5y equals +25. So when you multiply 5 times all of those terms, that's what you get. Does that look good? So I'm going to rewrite the second equation underneath, just so it's easier to see. And these are now our two equations. I've changed the equations so they look like this. So now I can simply add the two equations. And again, I like to have the coefficient one negative and one positive so we can add, because when you subtract, sometimes there's more mistakes that can happen. So I like to flip the signs and add. So this one, if we add negative 3 or negative 10 plus 3, we get negative 7x, right? And these ones just cancel out, give us 0y, so that's like it's gone. And then 25 plus 3 is 28. So divide by negative 7, both sides. You should get x equals negative 4. Okay, x equals negative 4. All right. So I'm going to go back to one of my original equations now and plug that in. So 2 times negative 4 plus y equals negative 5. Negative 8 plus y equals negative 5. Y equals negative 5 plus 8. Y equals 3. Okay, everyone agree with that? Okay. So we would do a quick check to see if those work. So I'm not going to write it out just for sake of time. You could write it out just like I have been doing for all the other ones. A quick mental check though. We've got negative 8 plus 3. That's negative 5, yep. And then we've got negative 12 plus 15 is positive 3. That works. Okay, so just doing some mental math check, and those are correct answers. All right, take a moment to do letter B, and I'll show you the answers here in a minute. So go ahead and do 6B, please. And if you've done 6B already, if you've done this question already, that's great. You can keep working on the rest of your homework. I'll come back to this and we'll check our answers. But if you haven't done 6B, I don't want you to do it right now. All right, let's check B here. See if you got the same answers as me. All right, so I see a negative 6 and a positive 3. So if I multiply the bottom one by 2, I'd get a negative 6 and a positive 6 there. So when I add these up, multiply that out. So 2 times 9 is 18, 2 times 3 is 6, 2 times negative 7 is negative 14. Okay, the two new equations, add them up, I get 21m. The n's are gone, and then I get negative 14. So when I simplify this, divide by 21, m is negative 2/3. Okay? Now the problem with fractions here is if you put this into a decimal, that's the problem with decimals, then you have negative 0.667, or where do you say negative 0.6 or negative 0.7? So your answers are going to be slightly off a little bit if you don't use the fractions, and that's the bigger deal. That's why we use fractions, because this is a very exact representation. A decimal always is approximate, you know what I mean? So sometimes when it's irrational like that, or sorry, when it's repeating decimal and you have to like round it, your answer is not very exact. So in calculus, which is kind of where you guys are headed in the future, we want to make sure we're as exact as possible. So working with fractions is important. All right, so if I get negative 2/3, I want to plug that into one of the original equations, which I plugged it into here in the first equation. 3 times negative 2/3 minus 6n equals 0. 3 times negative 2/3 is negative 2 minus 6n. So isolate for n, I get negative 1/3. Okay, so however you isolate for n here might look a little different than I did. But negative 1/3, you get that. Then to check, again, I just did an abbreviated check like I did last time. 3 times negative 2/3 would be negative 2, minus 6 times negative 1/3, that's 6 over 3 is 2, so that's minus a negative 2 is plus 2. So that one works there, and then they work for the second equation as well. So these are your answers. M is negative 2/3, N is negative 1/3. Yeah? Okay, if you solve for n first, that's fine. Then you just, when you get the n, now you plug this value into one of the original equations, and then into, wherever, there or there, and then solve for m. You tried? Oh, okay. Well, it should have worked. You should have got the exact same answer no matter which one you solve for first. Okay. Yeah, I can come check your work, but it doesn't matter if you solve for n first or m first. It shouldn't matter. You should still get the same answers.